to take care of your meshes, for instance. So typically the smoothness of a mesh is typically referred to by different names, expansion ratio or growth factor. If if you are dealing with maybe a different software, for instance, you may see certain names like expansion rate or growth factor. Basically, it's the same thing. And if you do work on any CFD simulation, you need to report this metrics, because this metrics would end up being something that your solution will be judged against. So if, let's say, your mesh metrics are bad, then your solution typically would go along with it. So this is something that is really important that you need to take care of. And in OpenFoam, for instance, you can always get this criteria by basically typing in check mesh, which we did try yesterday. So you just type in check mesh. After you've generated your mesh, you should be able to see those mesh quality criteria. Now, OpenFoam has a few recommended criteria there, which are generally conservative, which is that for the non-orthogonal threshold, right, the maximum you should have for non-orthogonality should be 70, but that is quite conservative. So you can use 80, but once you exceed 80, then you have a problem. So you need to be very careful when you look at the non-orthogonality. Now, for the skewness, typically 4 is what they recommend, but you can have a skewness of up to 8. If you begin to exceed some of these numbers, then you know you have a problem. Now, for today, I'm just going to try to make it a bit more interactive. So we are going to be trying to generate a few different meshes, but mostly we'll focus on generating meshes like this, O-ring type of mesh, which is basically when you're simulating flow through a pipe, for instance, which as chemical engineers is quite interesting to us. So we'll work on this, but mostly you would have to come up with the conditions, the various parameters that we need to be able to define in our block mesh. So I'll be typing, you'll be given the various issues, which is the various parameters or geometric parameters. Anyway, so for generating grids in OpenFoam, the first thing you do need is to specify the axis. So if you specify an axis of X, Y, Z this way, as shown here, for instance, and then you have to begin to think about the vertices. What are the vertices that you need to have, or the points? Because each geometry, for instance, each cell is made up of points, and those cells make faces, and then the faces make a block. So you need to start thinking about the coordinates. So if we start, and in OpenFoam, we start numbering from 0. So we go 0, 1, 2, 3. Now, the numbering, for instance, typically we go with the anti-clockwise direction. And that's how we form our blocks. So in this case, if we put our origin at this point, right, that is going to be our point 0. And so point 1 in the X is going to be this direction, 2 and 3. And then we move into the next space, which is in the Z direction. So for this, we have point 4, 5, 6, and 7. Now, if you pay attention, you see that point 0, we have 0, 0, 0. Point 1, we've moved 1 unit in the X direction, which is 1. The rest are 0, 0, 0. And then point 2 is 1, 1, 0. We've moved 1 in the X direction, 1 in the Y direction. And then we return to 0, 1, 0. So that is basically what you find in the vertices file when you open block mesh, for instance. So your vertices are basically 0, 0, 0, 1, 0, 0. And that is what we covered yesterday. Then you have to define your faces. Typically, you can ignore the numbering for the faces, the index. And then after you've defined your faces, for instance, well, you define your blocks as well. And then with the faces, you use the faces to now define your boundary conditions. So let's say for the case which we considered yesterday, which was the cavity case situation, we had on this side no slip, no slip on all other sides except this side where we are moving the top. So we would begin with something like this. But to even begin, let's just start with OpenFoam. Let's go to the terminal. And what we are going to be doing, this is the goal here. We want to generate a mesh for a pipe of radius 1 meter, which is very big. You can scale it down, but it's fine. Let's just keep the one. In this case, we can scale it down to centimeters, which is fine. So 1 meter, and the length, which is the Z direction, is 20 meters using block mesh. So who want to go first? What do you suggest? How do we progress? Remember that block mesh actually uses basically boxes. So how do we progress with this? Anyone? We need a game plan.
Dr. Nyadi, I think we need, I don't know, is it a mesh size or something?
Yes, we need a mesh size. That is one thing that we would have to define. But even then, we also need to, at least, if you remember, we need to know our coordinates, the vertices. So we need vertices. That's the first thing I would want us to look at. So who wants to go? Come on, try. Just say something. Okay, well, I'll try. So we need to define our vertices. Can we then split our geometry into something like this, into different blocks? Unmute yourself and speak.
Wow. So what? How many blocks are there? Is it 1, 2, 3, 4? 4 blocks?
There are 5. So 0, 1, 2, 3, and 4.
4. Okay.
So you can see if you put it here, basically I guess you put the middle one here.
Yeah.
So that is block 4. And then we can begin to move this way. But typically we have to go anti-clockwise. So we can split it into 5 blocks. And then we can merge those 5 blocks together. Right?
Okay.
Okay, now we know the radius to be 1 meter. Well, you can make it 1 centimeter. 1 meter is very big, but uh, anyway, so we know the radius to be 1 of this big block. Now we also know the length. So we need to come up with coordinates. This is basically what will happen if you begin to handle your own cases. You would know what your process needs, but you have to then specify. So how do we get the coordinates? Okay, so we need to now define vertices. So now we can begin from here. You can choose a different place to begin, but always remember you are going to be moving anti-clockwise. So for the front face, the back face, let's start from the back and sweep inwards or forwards. So we can then have at this point as our 0, and then 1, 2, 3. 0, 1, 2, 3. This is our block 0. Now you would also see that this point corresponds to the same point for block 4. And point 3 and 2 also corresponds to the same points for block 1, right? And so for block 1, we only need to define 2 front vertices, which are, well, we define for block 0 the front, and then we define for block 0 the back. And then we have to do the same thing for block 1 and all the other blocks as well, right? So for block 1, the back is basically, which is exactly this, 4, 5, 6, and 7, anti-clockwise. And then we go to block 1, which will be 8, 9, 10, 11. And the same thing, we'll just have to continue. So now let's try to put this in and then work with OpenFoam in the terminal. And let's try to generate this mesh. If we are able to generate this mesh, I'll be extremely happy. It means we've been successful. In the end, we should be able to, well, there's going to be an assignment where you have to generate a block like this. And we are going to be dealing with honor code here, which is that if you follow the lecture or the tutorial session today, you should be able to do this because this is relatively simpler compared to what we'll be working with. Originally, we were going to actually do the simpler one and then you would face this, but let's just do this.
So my question is that, so those
Okay.
vertices are continuous, right? So if 0 is taken, no other point can be called 0 again. Is that okay? Unless it corresponds to the same location.
No. Oh, okay. So, okay, hold on. Let me. You meant that if 0 is taken, no other point will be called 0.
Is that
So
so?
it corresponds.
Yeah.
So this is still 0 for this block. This is still going to be 0 for this particular block. Hold on. It's pointing. So for this particular block, this is still going to be 0
Yeah.
because it's the same point.
Point, yeah.
Yeah, it's the same point. And for this one, it's going to be the same thing.
0.
But if you notice, once we've defined all other blocks, we don't even need to explicitly define block 4 because everything then coincides.
Yeah, yes.
Okay, so I'll just fire up.
Please, I have a question.
Okay,
Please, I wanted
go
to
ahead.
ask. So we specify block 0 for both the back face and front face before we do the rest.
Yes. Yes. So yeah, okay. Now that sometimes it can be confusing, but I want you to look at this block, for instance, right? As an example. Can you see? So this is just one block, right? It has a front face and a back face. It's the same with this one, which is your pipe. You have an inlet and an outlet. So if you've now divided your pipe into different blocks, then each inlet has to have a corresponding outlet. Do you get it?
Yes, please.
All right.
Doc,
Yep.
is it possible that we can consider maybe dividing it in different ways, and would that affect the quality of what we are going to do?
Um, in different ways, as in
No, maybe instead of dividing it into the 5 or 4 blocks you were mentioning, what if someone
yes.
was able to maybe cut up the geometry into maybe 6 or 7, with maybe depending on the kind of geometry that they have? Would that improve the quality or reduce it, or it wouldn't really have an effect as long as the vertices are well defined?
So long as the vertices have been defined and you don't have any overlapping faces and surfaces, you'll be fine.
Okay.
So this is just an example, one way of doing it. If you deal with maybe the assignment, for instance, right, which is something that is simple, well, you can divide this into multiple ways. You can choose to divide this, for instance, you can choose to go this way. Oh, great. I don't have, well, someone can choose to go this way and then basically have 1 and 2. Someone can choose to go this way and have 1 and 2. Others can even do multiple. Do you get it?
Yes, please. Thank you.
Yes. Yeah, so it is relatively flexible so long as you are obeying the fact that everything is forming a right-handed system. So
Okay.
you are good to go.
Okay. Thank
Anyway,
you.
yeah. So let's just move in and then say C. Okay. Okay, let's move into this.
So, Dr. Bak, so
Yes.
this is like taking a small cross section of the pipe.
Yes.
Okay.
Yes. So we are basically taking, well, I didn't draw it, but then um, just think about the pipe, right? You just have a circle, and then you extrude in any direction, right? So if you have you are the inlet, that is what you see, and then if you extrude, you can basically extrude towards you or away from you. So that's basically what it is. So let's make directory, or we can just copy from the initial tutorial, which is, let's go to CD, CFD course. Okay, so I'm just going to copy, I'm going to copy block mesh, because that's the only thing I'm going to be working with, but we can just copy the whole thing. Are you following?
There could be a way of the screen being bigger, like your.
Oh, okay. Can you see?
Yes.
And then let's just call it pipe.
Hello, Dr. Baga.
Yes, please.
Please, I think our cavity directory, we don't have block mesh.
What?
We don't have block mesh like in our cavity directory.
Oh, wait. Let's just, what do you have? Can you show me? Share your screen.
Okay. This is what is there.
Oh, so you should have it in the system. So yeah, you should have it in the system. But before you copy, clean this tutorial, or you can copy and clean it. Copy and clean it first. So if you remember, let me share my screen. You have it there. Yeah.
Should I copy the system?
Yes, copy the whole case file, and then you can clean it once you are in there.
Should I copy
Can you
to my
see?
my CFD course?
Yes, so copy it there. Copy it into that. So just use this command if you have the same file directory name, then you can just copy it there, or whatever the name is.
Okay. So now I should clean it.
Yes. So CD type.
Home cleaner.
Yes. Foam clean tutorial.
Mm.
Okay, so I also have log files, so I'm going to be removing these log files. So they are
This thing
gone.
was
Dr. Bagi, please. I don't have pipe mesh.
So you need to copy the previous cavity case we did and then just rename it. So that's what we did.
The main tutorial directory.
No, well, I'm copying from yesterday's tutorial directory, but you can copy from the main tutorial directory as well.
Okay, sure.
Hmm.
have to copy the copy file for the
Okay, by the way, not something I encourage you to do, but if you go into, I think you should be able to see Linux. So you should be able to actually copy or even work manually like you normally do in Windows. So let me just share this with you so you can see. Okay, so I'm sharing my full screen. And so if you look here, you would see I have Linux. I'm not sure if you have it. And so you have this here, Ubuntu. And so if you go to home, you see I have the same directory that I've copied. So you can do the same thing. You can just say, hey, let me copy this and paste. And then you can rename it if this works better for you. But I think it's best to practice on the command line. Do you get it?
Yes, please.
So that is just in case. Okay. Anyway, so if you are ready, we can proceed. Should we proceed?
Yes, please.
Okay. So now that we have this, we are here, we can go into our system directory, and then look at block mesh. Okay, so block mesh. So this is what we had. So at this point, we need to get a few things here, which is that we need to define vertices and all that. So I'll move back to the PowerPoint so that you can actually give me the vertices. So do you have a calculator?
Yes,
Hello?
please.
Okay,
Yes.
so what do you think? We need to decide on certain stuff. So what do you think should be the inner radius or inner diameter, the inner radius for this? So we need to define a few things. What should we choose as the inner radius? So we can choose 0.354. What do you think?
0.354.
Yes, for
Okay.
the inner radius. So now what we then have is we have two radii, inner and outer. The inner radius basically is from the center to the box, the edge of the
Okay.
box, right? So
Yeah.
what will be this, the coordinates of this vertex when 0? What is it going to be?
Come again.
Yep.
Please, we didn't
So
hear.
for point 0, for instance, we need to come up with the vertices.
Yeah.
So for point 0, vertex 0, what is it going to be? Take your time and do the calculation.
Dr. Bagi,
So, yeah.
please, we are still not finding the pipe mesh.
Okay, show me what you have. I'll stop sharing and then you show me what you have. Okay, so we had the first one. Someone said negative 0.25, 0.25, and 0, correct?
Negative 0.25, 0.354, and then 0.
0.354 and then 0. Why is it 0.354?
We said the inner. I'm coming a minute.
Okay.
Yes. So it's negative 0.25, then 0.25 again.
Okay, and then 0. Okay,
And then
great.
0. Yes,
Anyway,
please.
so can you explain to us how you got this?
So what I did was that for the where we have block 4 labeled, if you are saying the inner radius is 0.354, so that's from the center
Sorry, 1
to.
minute. Dr. Nyadi, can you make it bigger? Just the diagram.
Okay. Yes, keep going.
So if we are taking the
Okay.
inner radius from the center of where we have the 4 labeled to the corner, we said that is going to be 0.354. So it means the diameter is going
Yes.
to be twice of that. And then since it's a square, the edges are going to have the same length. So I just use the Pythagoras theorem. So a squared plus a squared should be equal to d squared. Then I made a the subject. So that will give me the length of the side of the square. And then I divided it by 2 to get half of that. That's where I got the 0.25 from.
Nice. Anyway, so your approach is quite different from the approach I used. And the
Okay.
approach I used was basically to now switch the coordinates, right? From the Cartesian to polar coordinates.
Oh,
And
okay.
you know that in the y direction you are going to be having the radius multiplying sine of the angle. And then in
Yes.
the x direction, it's also going to be whichever radius you have multiplying sine of the angle, right? And at
Yes.
this point, if you look carefully at the way we divided it, it's likely, well, we can just say that this particular point, hold on. This particular point is 100 and it's in the second quadrant, right?
Yes.
So the angle is most likely going to be 135. So 135, and with that sign 135 multiplying the
Okay.
radius, which is 0.35. And so we have the y direction, and we do the same for the x as well.
Oh, okay.
So that's one way, but you see that there are different ways to arrive at the same answer. This is why I wanted us to walk through it.
Okay.
Anyway, so let's continue. I actually didn't do the calculations. I did it, but then it was a long time ago. So let's continue.
Okay.
So
So I think
point one.
yes. Point one, I'm coming. Point one would be
The angle is the same.
okay. So if it's 135, but then this time we are going to be using an R of one.
Yes.
So then it's going to be so it will be minus 0.707 for the X.
Okay.
Then for the Y, sorry, I
Yes.
mean the angle. So,
Hold
sorry, that
on,
will
let
be for
me
the Y. Okay.
hold on. And then
It would be 0.707 for the Y.
correct.
Okay.
Do we have it?
Yes,
Yeah.
please.
Okay. So now let's move on. Next.
Okay, so
I want to hear from other people as well. I want to hear from other people as well. So now let's move on to point two. What is it going to be?
Or maybe is the angle 45?
So yes, for point two, the angle is going to be 45.
So, and you said y is the r sine 45. Y is r sine 45.
Yes.
So that becomes 0.707.
Okay. So let's do this. So here we have what is our x?
I think also 0.7. This is sine 45. Let's call it cos 45. That's also 0.707.
Okay. And then this is, let's call it point two. Here I'm just commenting the two dashes
okay.
in. Yeah, this is just a comment so we can track the various vertices.
So
Okay,
we can
now
do the
let's,
same thing. We can do the same
yes.
thing in the terminal.
Yes. So yeah, so we can do the same thing. We are just marking our progress here, which is
Okay.
that so let's say if we go back to the terminal, for instance, I could have just done this, which is say move on and say and comment. You can see
Okay.
it's blue. It's
Yes,
commented.
please.
So I can call
Thank you.
it 0.
Okay.
It's
And
about
so since yeah,
please, I'm a bit confused.
okay, go ahead.
Please, I wanted to ask about the inner radius.
Okay, inner radius, yeah.
Arbitrary.
Have I tried? I couldn't hear you. I can't hear you.
Yeah, I was asking how you got it. Is this
So, okay, so with the inner radius, you can choose your own inner radius because you are free to choose your own inner radius.
But I'm guessing, but it must be between 0 and 1 because the main radius is 1.
Yes,
And the
yes,
one
it's
is something
smaller.
between 0.
Yeah, it's smaller than the outer one. So anything between 0 and 1 works. Okay, let's move on. So we have 0.012, and how about 0.3?
Oh, we see. That's 0.3. That's 0.3. Please, that's 0.3. Okay. Is that where the radius was? Is it point some? What was the radius there again? 0.3.
54.
0.354.
So I think it should be the numbers for you got, but remove the negative from both of them. Like the first point.
Okay, but then what about the sine of the angle? The angle here is it's what's the angle?
I think it's still 45,
45.
but it should be on the same
Okay.
line with, is it 0.2?
Yes. Yes. So we move back. And so here we have
So 0.25%.
Yeah.
so 0.25, 0.25, and 0, right?
Yes.
Yes, please.
Okay. Now we need to define the other side for the opposite side, which is the front end of the block. So we can just copy this. Whatever we had is the same thing, right? So 0.4, 5, 6, and 7. So now we need to update the Z direction, which we said it's 50, right? Is it 50 or 20?
It's even started from the 8.
What?
So that would be the length of the pipe, right?
Yes, the length of the pipe. So we said it's 20 meters or 20, right?
Yeah.
So 20. And here should be 20 as well.
Doc,
This is some form of is it cylindrical coordinates in a way.
Yes,
where there's
basically it's a cylinder, so it's easier to work in cylindrical coordinates, but that is basically what it is.
Yeah, no, thank you.
Anyway, so we have our first block defined. Can we do the
Doc,
same? Yeah.
so if we are in the terminal and we want to just copy the first 4 we did, and then just change the 0 to 20, I tried control. If I use control C, you won't be able to copy it. So what do we do there? Or we have to type everything out one by
You
one?
have to type it out. Yeah, you have to type it out. Yeah.
Yes, please.
Okay. So
Hello, Dr. Badu.
yes,
With the coordinates, could you just go,
the coordinates.
yes, like how
Okay.
you came up with it? Because we're still trying to find our block mesh direction, but we found it now. So just an
Okay.
overview.
Okay. So how the direction, right? So basically we are converting from the Cartesian coordinates to cylindrical coordinates, which is that our y, whatever our y is in the Cartesian coordinate, is basically equal to r sine theta, sine of the angle, and then the x is r sine r cos of the angle. That's it.
Okay, I get it now. Right. Okay, so we can continue.
Yes. So now let's define the next vertices, which is the next block. Hold on. So let me just put a comment. Sorry, I wasn't sharing. Share. So let me just put a comment here and see this is block 0. Great.
Okay.
And then now let's do block 1. So block 1, only what do we need?
The angle, anyway.
Yes, we do need the angle, but we only have these two, right? Hold on. So for this, for block 1, we only need points 8 and 9 because we already have 2 and 3.
Yes.
Right?
Yeah.
So what would be the angle?
Is it 360 minus 45?
Yeah, 335. Hey, no.
315.
315, yeah.
Okay, so plug that in and let's see. What do you get?
So That's
The inner radius was what again?
What?
The inner radius.
Yeah, so it's 0.354.
1.35. Oh. So one of them is minus 0.25. Which one is minus 0.25 again?
Which
that would
one?
be the Y.
Is it a 5? It's minus 0.25.
Okay, so are we okay, y, okay. So the y is minus 0.25. Is that what you said?
Yes.
And then the x is
Positive.
okay, what is it?
What's 0.25?
Okay.
Is it? Okay.
Yes, please.
Okay. And then 0.9, what is it?
One of them is minus 0.707.
Okay, minus which one? X or Y?
I think
We
the
need to.
correspond whatever was negative is still the one which is negative.
Okay. Okay, so 0.707. And then
Then positive 0.70.
okay. So basically this is it. And we need to define the back and front as well. The
This,
back.
have you missed it up a bit? Which one is the X? Isn't the X the positive and the Y there?
Okay.
Can,
So
can we see the geometry again so that we can confirm?
okay. So this is it.
Yeah, the X will be the positive because it's kind of on the right side of the quadrant.
Okay.
And the Y being the
Okay.
negative.
Okay. Anyway, so let's just continue. So the x is positive,
Positive,
correct?
yeah, Y
Yes,
negative.
please.
Yeah.
Y is negative.
Yeah.
Okay. For which one? 8 or 9?
9.
Okay. X is positive, Y is negative.
Yes, please.
How about 8? Is it the same?
Yes,
It
X
should
positive
be.
Y.
Okay. So same thing
Yes.
here and here. Okay, this is 20. Anyway, so one thing we could do now is actually, let's just generate this mesh first, this block, the block 0. Let's do that, and then we can come back and see. So I'm just going to move away and then come here. So here. Okay. Okay, so let's just save this. Yes, enter. And so now I'll exit and generate mesh. Great, we have an issue. Okay, let's go back. Let me exit. You'll define. Okay. Line 22.
Please with the comments on voice note, space in between. Can you be there?
Which one?
I think the comment too.
The what? 2?
Yeah.
Oh, yeah.
Okay.
Here. Yes. Thank you very much. Nice catch. Yes, I think that is the issue. Let's see. Okay, so we are facing another issue, which is the ordering. It's inside out. So let's look at it again. Let's make sure that ordering 111 line 32. So okay, let's look at the ordering here, just so we are sure of it. So 0. Let's make sure, please let me know if I got the coordinates right. 0, 1, 2, 3. 0, 1, 2, 3. Okay, let me see. So, oh, I see. So now in this case, we have to go 0, 3, 2, 1, and then 4, 7, 6, 5.
Oh, anti-clockwise.
Yes, so if that is very important, and the good thing about doing it here is we get to make the mistakes so you can all see it. So if you look carefully, the hex that we defined should start from 0, 3, 2, and 1, and then we have 4, 7, 6, and 5. So we need to correct that in terms of our grading. So we need to correct this. So here, if you notice, the hex mesh is defined differently, right? The ordering here, it's very important. We always need to form a right-handed system, anti-clockwise. So we have to go 0, 3, 0, 3, 2, 1 instead of the 0, 1, 2, 3. So here,
Please, why are you changing the order?
why am I?
Which part are you changing the order, please?
The blocks here. Can you see?
Yes, please.
So 0, 3, 2, 1. 0, 3, 2, 1. And then we begin again from 4, 7, 6, and 5. Do you get it? Anti-clockwise.
Yes.
The blocks should be numbered according to this: 0, 3, 2, 1, 4, 7, 6, 5. That's the first block, correct?
Yes, please. So Doc,
Yeah.
so if we specify the other coordinates for the other block, should we take it out for now? Or we can leave
Well,
it?
yeah, we can leave it, but then it shouldn't affect anything because
Okay,
you
yes.
haven't included it in the block. So
Okay.
you can leave it.
Yes, please. Thank you.
If there is any issue, you just delete and start. That's the beauty of CFD.
Yes, please.
Let me see. And in the meantime, let's comment out these boundaries. Let's see. So I've commented out the boundaries for now. Are you also facing the same issue?
No, please. But
So you were able to get it?
yes, please. I'm coming.
Okay, then that's good. Anyway, so then in that case, I can just redo.
But then, no, please, how did you comment out the boundary again?
So you just a slash and then the multiplication sign, and afterwards,
Okay.
so you do this basically. So if you want to comment out a block of code, you basically like this, and then in the end, this. So everything else between this is going to be commented out.
Yes, please. Thank you.
All right, no problem. Anyway, so let me deal with this issue and see. Okay, so I'm just going to save this, copy it. Okay, so let's try this again and see. Okay, so we are all on the same page now.
Yes,
Hello?
please. Yes,
Yeah.
please.
Yeah, so can you see my screen?
Yes, please.
Okay, so that's fine, that works. Anyway, so now we need to go into block mesh. No, PowerFoam and see what we have. You can see it. It's a slab.
Please.
This is exactly what we were talking about. So let's see, numbering. Okay, so the names are being shown here, which is fine. We can also remove stuff. So we got the first one right.
Yeah.
Okay, so we need to proceed and finish up with the other part. So can you fill this in?
Yes, please.
So I'm just going to end this and then we continue. Is anyone lost? Is anyone having an issue?
I had the same, but the names are not on it.
You had what? Hello? Hello? I couldn't hear you.
Hello, Simpson.
Simpson?
Ah. Simpson, were you saying something?
I think he was saying he had the same thing, but then the names were not showing up on it. It was a similar
Oh,
thing here. I was like,
oh, so the names you can basically okay. So the names is not a big issue. So long as your mesh is right, I'll show you how to get it. So if you play around in Paraview, you can you see my mouse?
Yes, please.
So you
yeah,
can see show patch names.
oh, okay,
Do you see that?
yeah,
So if you click on it, the name and then you apply, the names should show. So typically you can use that to check in maybe in the future.
Dr. Nyadi, I'm asking, the part that looks
Okay.
flat,
Yes.
shouldn't it look like
This
curved?
okay, so we haven't finished yet.
Okay.
So you would notice that we've that's a very good question. So we are building this systematically.
Yeah.
So the next thing is after we finish, we need to define an arc
Okay.
so that it's no longer flat.
Okay.
So that is basically the next stage.
Okay.
After we've defined the blocks and all that, the next stage is basically make sure that it is curved.
Okay. Thank you.
But it's always good to make sure that whatever you intended to do is exactly what you are seeing. Otherwise, you have to stop and then start all over again. That is the only thing.
Thank you.
All right, no problem.
Please, I think my network was not stable, so I didn't see what to do.
What happened? Okay, so I'm just going to close this. You can even show grades if you want. So if you want to investigate in terms of grades, you want to see whether or not the parameters, the values you entered are actually correct. You can see that if you show grade or show axis, show data grades, it should show. And if you show axis grade, it basically is the same thing. Can you see it? Can you see it?
Yes, please.
Have you been able to do that? So basically, after this, you just have to play around. You are not going to break it. Whatever happens, you can just stop or delete your keys and then start all over. That's something you should always feel confident in doing. So I'm just going to close this and then we can continue. Should we continue?
Yes, sir.
Yes, Doc.
Okay. So I'll move in there and then go back to Nano and block mesh edit. And so we have this. So I'll now move on from here and say, okay, I have block 1. And then this is block 0. Anyway, so block 0, block 1, we have 0.25 minus 0.25 and 0. And we are calling this 8. And then we have 0.7071 minus 0.7071 and 0. Those. So are we all on the same page? The next thing is basically let me see if this works for me. Okay, so I've been able to copy and paste. And basically, if you copy, after you've copied, just right click and it should work. Instead of saying Control V, wherever you want to paste, just right click. Is anyone else having a problem?
Yes, I wasn't able to do the copying.
So Control C, once you highlight it,
Okay.
Control C.
Share your screen again.
Oh, okay, hold on.
Control C.
Yes. And then you put it in there, Control V.
When I press Control V, it's giving me the
No, you don't Control V. You just paste it in there. Like you right click.
I think with the commands that the paste is Control U and the tab is Control P. I don't know if that one works.
Okay, so if you are going to be copying and pasting, just after you've copied and wherever you want to, just right click, and then that's it.
Yes, please.
No, please, it's not working.
Then type.
Okay, then just type it out.
Please, can you share your screen again?
Okay, hold on. Sure. Can you see? So now we need to make sure that the numbering is right for this block. So what is going to be the block? Numbering.
We have to see the diagram again.
Okay. So tell me and then we can add it to it. For this block. So let's go 3, 8,
3 is already given.
9, 2.
Or you still have to do it. You said 3 already correspond to.
You have to do it. You have to do it. So 3, 8, 9, 2.
9, 2, yeah.
And then we go 7, 10, 11, 6. Right?
Yes, please.
3, 8, 9, 2, and then 11.
17.
Oh, okay, sorry. 3, 8,
9,
3,
2.
8, 9, 2, and then 7, 10, 11.
7, 10, 11, 6.
Yeah. So we are good with this block. Let's test it out.
Yes, please.
Another issue. Okay. So I'm just going to take out the boundaries first. So we are having issues because of the boundaries. So let's comment out the boundaries. So I'm just going to comment out this. I could do it in block, but I want to do it manually so that we don't have issues like the last time. All right. Okay. So nothing, the boundaries have been commented out in my case. So I've commented out the boundaries and we don't have that issue anymore. So typically when you have an issue, just read what you are being told on the terminal. You most likely be able to find the issue and then you can just fix it. Do you have any issues?
No, please.
So we are on the same page.
Yes, please.
Okay, good. So now let's check. So you can see that we have two sides. Can you see it?
Yes.
Yes, please.
Hello, Dr.
Okay, so we
Wagner.
also need, yeah?
I keep getting this error on PowerPoint.
Okay, so then share your, you said you keep getting error from where?
PowerView.
Okay, and what is the error?
Could not find valid OpenFoam mesh.
Could not find valid OpenFoam mesh. Can you share your screen? Did you type in PowerFoam or PowerView?
PowerFoam.
Okay, let me share your screen.
I'm joining from that device, so
Okay. So one thing you could do is, instead of using PowerFoam, why not try PowerView? And then, so okay, let me just show everyone, just in case this works. Most likely it should. But let me close this, and then you can see it. PowerFoam basically loads your case, but then if you type in PowerView, right, you have the same thing. But now you don't have a case to just apply it. So go out there and go into your system, it's all, and then now your control deck. That's what you are going to be clicking.
Okay, we are not seeing
And
anything. Hello.
oh, you can't see.
Yes.
Oh, I see. Sorry. Sorry. Let me just share my screen.
this is not your typical number, whatever.
Dr.
Sure.
Wagner.
Yeah. So if PowerFoam isn't working for you, what?
To continue.
Hello?
Hello,
Okay.
Dr. Wagner.
So if PowerFoam, hello?
Yes, please.
Okay, if PowerFoam isn't working for you, you can just type in PowerView, right? And it should give you the same thing. But here you have to load it yourself. So here you need to load in, go to your system, all files, and then control dict. All right. And then OpenFoam Reader. Right? Apply. So you should have it. Just apply. So you have it. Yes.
You have both. Okay, nice.
Yes. So then we need to complete the next two
Yes,
as
please.
well. Okay, so who has the coordinates?
I'm thinking, so if you could see it,
Okay.
like, no, I'm thinking even if you could see the old one, like what you have already written.
Oh, okay. Yeah, well,
because it
then
looks
you
like,
would probably just,
yeah, there are 4 quadrants. So one where all of them are
yes,
positive, one where, so now if we shifted to the next quadrant, it is both Y and X
yes.
being negative by the same
So
point.
we are here.
So yeah, when you shift to the third quadrant, it's both X and Y being to the same point, but X and Y being negative.
Okay, so X and Y would all be negative, right?
Negative, yeah.
Okay. And so here, let's just call it, so this should be 12, 13, 14, and 15. So we can enter this, but let's finish it up. And then how about block 3? Block 3. So in block 3, what do we have?
Not big enough. Please could it be slightly bigger?
So block 3, we basically have the same definition, right? We already have the 12 and 13, right? 12 and 13 corresponding. We've already defined those.
Yes, please.
And so, yeah. Anyway, so we can complete this and move on. Hold on. So block 3 is basically going to be 12, 13, 14. 12, 13, 14, 15. That's all.
Okay.
12, 13, 14, 15. Which is
So
exactly the same.
kindly share your
Yeah.
your
Oh,
work
okay.
screen.
Oh, okay. Sorry. Mhm. Okay, so we have block 0, block 1, and then we need to include block 2. And basically, we have to define block 3, which basically corresponds to the other side, right? Okay, so now block 3. So block 2. And okay, so who doesn't have this?
You are now typing it out.
Okay. Yes, some housekeeping. Let me know when to continue, when you're done. And
Please,
we
yeah,
need to
that's
also do, okay,
please,
the block
should we
numbering.
run it?
Yes. Are you done with the block numbering in terms of hex?
We have to add the hex.
I'm done with block 2.
Okay, so you need to include blocks. Okay, so share your screen. Let's see. What do you have?
So it's left, we need to add the block 3.
Okay, so add block 2 and block 3, and then let's see what you have.
Okay, Doc.
Okay.
So please, can we get the order for block 2 again?
Okay, so block 2 is basically 8. We are starting from 8, and then we move on to 12. 8, 12, 13. Hold on.
Okay.
Yeah, 8, 12, 13, and then 9. And then we do the same thing. 10, 14, 15, and then 11.
Thank you.
Okay.
Doc, sorry, but
Yep.
please, could you go over the block arrangements for block 2?
It's
Okay. Hold on. Hold on. I'm coming. Let me just finish this up, and then we can all just look at it. There are 12. Hold on. 12, 8, 3, 4, 14, 10, and 7. Okay. So this is what I have.
Okay.
Yeah.
I think you have the hex for block 3, but
Yes. So
this
I
one,
have the hex for block 3 as well. So 0, 1, 2, 3. So these are what they are supposed to look like.
But have you defined the coordinates of block 3? All of them are already defined in 0, 1, and 2.
So basically everything block 3, if you look carefully, you'd see that. Can you see here? Can you see?
yeah.
You see that block 3 has the 12 and 13 corresponding to block 2. and then the 0 and 1 also corresponding to block 1, block 0.
Zero. Okay, so yeah, means that everything was already defined. Yeah.
Yeah, so everything has already been defined. So all we have to do is just add it.
Yeah. My next question is I see some 200, 200. What is that? Anytime we're doing the hexen.
So that's the number of mesh elements in each direction. So the 200 is 200 in the x direction, 200 in the y direction, and then 1 in the z direction. But then here we need to actually include stuff. We also need to include the z direction as well, because we have 20 meters there. So we need to actually include it. And in this case, it has to be even larger than the x and y. So even if we make this 20, 20, 20, or yeah, and this probably should be 100. You can do this. Yeah. So this should be it. And we can save and exit.
Look, why does it have to be higher?
Because that's the length. The z direction is the length of the pipe. And we said it's 20 meters. So you need more elements in that z direction. Along the length of the pipe, you need more elements. So even the 100 might not be enough, but for now, let's just test this case. Otherwise, you may not leave early.
Hello, Doc.
Yeah.
Please, we've not added the block 3 vertices.
You did not add the block 3 vertices?
Yeah, from yours.
Oh,
It has no unique.
okay, I see. You don't need any vertices in this case because everything corresponds. Do you see it? Let me show you. Hold on. Let me share this with you.
Yeah, I think so.
So here, you see, you can see that for block 3, the entrance or the beginning, 12 and 13, are basically the same as block 2. And the end is also the same as block 0.
Block 0.
And do you see it?
Yes, please.
And then it's the same thing here as well.
14, 15.
So block 4, we don't need to define it as well. Block 3 and 4, we don't have to define.
Because they've been completely defined by the other ones.
Yes, so everything has been defined by the other ones.
Okay, please. Thank you.
All right, no problem. Okay, so should we proceed?
Look, it's a minute.
Okay, no problem.
Please, when we were defining the blocks, the part where we had the hex, I think for one we made it 0, 12, 8, 3, 4. I wanted to check it again with the geometry because I'm not seeing the order for the block 3.
The order for block 3. Oh, okay. I'm coming. Let me see. Hold on.
Okay.
Sure. So you want this order, right? Is that what you wanted to see? Or
Yes, please. So the 0, 12, 8, 3, 4. Okay, so the that one is for block 4.
block 3.
Block
Starting from 0. We are numbering from 0. 0, 1, 2, 3.
I think I'm a bit
I don't know. So I don't know if
confused.
you could make it a bit bigger.
Okay. So anti-clockwise.
Yes, please. So okay, Doc, let's say we are starting
I
from
think
block
it's
2.
01, 12, 01, 13, 12.
Yeah, so they
But
do this.
Yes.
sorry, I was asking because I'm coming. Let me try and put my thoughts together. When we're doing
Okay.
block 2, we started from 8. So I thought we'll start from the one closest to the previous block we just did. So I was thinking that maybe
No,
in this started. Oh, okay.
no. So basically, so long as you keep going anti-clockwise, then everything should work.
Okay. So I can start from 0, 12, 13, 1.
No, 0, 12. Let's be on the same page. 0,
01,
12.
12, 13.
Yeah.
0, 1, 13, 12.
0, 1, 13.
Yeah,
Okay.
well, yeah.
0, 1, 13, 12. Again,
Yeah. You can do 14, 4, 5, 15.
you said 14.
4, 5, 15.
Okay, thank you.
So you're on block 3, or which one are you on?
Yes, please, block 3.
Okay, I see.
14 what again? 14.
14, 4.
Okay.
They do it.
So
Would you do it?
hold on,
Yes,
hold
please.
on,
So
hold on. Okay, so
Mute yourself.
Hello? What's happening?
yeah, hold on. So have you tested this in Parafoam?
Yes, Doc.
Okay, and do you have any issues?
No, please.
Okay, that's good. Let me test this and let's see. Okay.
So we currently have something like a cuboid with a hole in the middle.
Oh yes, so you should add the last one. You should add the last one. Hold on.
That's correct.
Hold on. So I'm I'm going to project soon, but let me just round this up so we can finish quickly.
So Cuboid with a hole in the middle. It means that if we're
Yes.
pipe, then we will not have to, I don't know, hex that middle. We leave the middle space, or it doesn't matter.
So you need to no, well, but you need to include the fourth one as a block as well.
Okay.
But you don't need to define its coordinates. You also need to include that.
Okay.
So the fourth one would actually be basically that should hold on. Okay, so the very last one is, in my case, I have the last one to be 0, 1, 2, 0, 12, 8, 3, 4, 14, 10, 7. And then the third block is 12, 0. Okay, let me just share this. Can you see? So this is what you should have. So all the blocks have to be defined.
So I'm thinking all the blocks come together to make the fluid
Pipe.
region of the pipe.
Yes.
So where the fluid will pass if it's entering.
Yes.
Okay.
So if you have this, we can proceed. And now we need to define the edges. This is where now we need to define the edges, right? So for the edges, if you go to the link I shared earlier, typically you would have it there, but let's just do it here. And afterwards, you can look at it. So all right, here. So the edges, basically we need 2 points. Can you see? Can anyone share their PowerForm so I know where we are? Can anyone share?
His Martin is sharing this.
Okay.
Can you see my screen?
Okay. Yeah, let me see.
Is it showing?
Yes. So you have it. You have the block. So you are right, and we can continue. So now we need to define the edges.
I should keep sharing.
Hold on. Let me just finish this up, and then I can just share this with you. So for the edges, we have 3 edges. So what we can do is say arc. Hold on. So let me share this and then we can continue. So can you see? So for the edges, okay, make sure that this is not capitalized. And so we have for this block, right? For this one, hold on. So for these two, we have an arc here, right? This edge. We have an arc here, which is starting from the beginning is 1 and then ends on 2. And then we need to provide 1 point that the arc has to go through, an interpolating point. So at least we know that in this particular case, it has to go through 0, and then in the y direction, there has to be a 1 there. It has to interpolate at 1. There is a point where the radius is equal to 1, right?
Yes.
Yes, please.
So we have 0 on the x, 0, 1, 0, basically.
Yeah.
And then we can do the same thing here. So just 0, 1, 0. This is on that side. And then we can do the same thing as arc. And let me check. 5 and 6. The beginning is 5 and 6. We start from 5, we end on 6. And then we need to interpolate. 5, 6, and then we have 0, 1, and 20. Correct? And then we can do the same thing for block 1. And so for block 1, we have, let me just copy this. So for block 1, we have, basically 2 and 9, 2 and 9, and then
Okay.
2, 9, and we also have 6, 11. Correct? And so here we need to make sure that at least one of the points is going to be, yeah?
Sorry. Okay. But coming 0, 1, 0.
Are we all on the same page?
Yes.
No, please.
Okay. No?
Okay.
Okay.
Yes.
Where are you lost?
Please, could you go over the edges? How to
The edges. Okay, so with the arc, so we want to interpolate. We want to get this value, right? So we need 3 points. The starting point, the ending point, and the point that we can interpolate. Correct? So in this case, we know that, okay, hold on, pointer. So we know that if we are interpolating between this and this value, there is a point where our radius, when we start from the origin, there is a point where our radius is going to be equal to 1, right? In the y direction, right?
Yes, please.
Okay, so in that case, the coordinates of that particular point is just going to be 0, 1 in the y direction, and 0 in the x direction. And in this case, we have 1 in the x direction, 0 in the y direction, and 0 in the z direction as well. So you need to do the same thing back and front. Do you get it?
Another one will be 0 minus 1. So down there will be, is it 0 minus 1, 0?
Yes. So the next one is basically okay, here, right? So the next one is block 2, which is 9 and 13, right? And 11 and 15. And this has to be
0 minus 1.
9 and 13. Okay, yeah. So 0 minus 1, correct?
Yes.
And 0. And then this is also going to be
0 minus 120.
Yeah, 0 minus 1 and 20. And then we do it for the last one, the last arc. This is block 2. And then block 3. Don't forget to put a comment there. Okay, so block 3 is basically we are interpolating between 13 and 1, right?
Yes.
13 and 1 and 15 and 5.
Yes.
Okay, so 13 and 1, we basically have
Minus
negative 1.
1, 0, 0.
Yeah. And then
Minus
same
1,
thing,
0,
minus
20.
1. Okay, yeah. 0.20. So this is it. If you are done, let's see your file. Share if you're done. So just put all of this into your block mesh and let's see. Do you have it?
Yes, please.
Can you share your screen?
Okay, coming. Please, can you see my screen?
Okay, let me see. No, I can't. For some reason, I can't. Let me stop sharing. Okay, let's see. Share your screen again.
Okay. Should I show it in paraform?
Yeah, so finish it up and let's see.
Okay.
And let's see.
Can you see the paraform screen?
Yes, I can
Okay.
see.
No, please.
No, we cannot see. You can
Okay,
just see
come,
the
let me.
Share. No, I can't see the PowerPoint.
Okay, no.
Yes,
That's it.
so, yep, that's it. And no, don't close it. Don't close it.
Okay.
Let's see. So, make it bold. Okay, now show instead of surface. Can you see surface at the top? No, not that.
Yes.
Surface.
Yes. Okay.
Mhm. Click on it, and then
Okay.
what do you see?
3D glyphs, feature edges, outline, points
Surface
Gaussian.
with
Yes, the
surface
total
with edges.
Yes.
Yeah, surface. Show that and let's see. And
Okay.
apply. Yeah, so that's your mesh. Zoom in.
Okay.
So, yes, you've successfully generated your mesh. Has everyone been able to do that?
No, please.
Yeah.
My
So,
platform is Doc,
yeah,
please. My platform
Martin.
has one end to be solid and the other end to be hollow.
So I think you didn't define the fourth block. I think you need to make sure that you've defined. Martin, can you share your coordinates with everyone? Share your block mesh so that he can follow. You can look at it and follow. Martin. Oh, who was this? Martin, right?
So this is Kuju.
No.
Kuju.
Okay, could you
Okay.
share your screen? The guy who just showed us, the gentleman who just showed us his block mesh. Share
Yes.
your block mesh coordinates. Yeah.
Okay.
Okay, so I think up until this point, we all had it. Keep
Yeah.
going. I think this is where people got lost. So keep it here. It's
Okay.
okay. At the blocks. Please make sure that you have the same numbering for the blocks. Okay, and then your edges are also the same. So yeah, that's it. Do you still have any issues?
Please, I'm about to run it.
Okay, run it and let's see. Do you have issues? Do you have it?
Tabagi.
Yeah.
So it means that the edges are only used when you are trying to create some circular thing. So assuming it was
So
square.
the edges, oh yeah, so the edges are used when you want to create curves.
Curves, okay.
So
Yeah.
if you want to create curves, that's when you use the edges.
Okay. So if it was square, we don't have to worry about it because it will already be straight.
Yes, if it's square, then you don't have to worry. So typically, if you want more information on this, you can read up on it from the link I shared, but I can still show it here.
Should I stop sharing?
Yes, so that I can just show everyone. So, hold on. So you can see it here, just block mesh utility. And so you have the various components to your block mesh dictionary. You can find all the information here. So you have basically for the curved surfaces, that's when you use the edges. So you use an arc for that. You could also use maybe simple spline or whatever more complicated lines.
Something to generate them. Doc,
Yeah.
please, in Power View, what command did you use to generate the mesh?
So the mesh is already generated the moment you type in block
Surface
mesh.
with surface with something.
Can you share your screen? Share your screen so that we can
Okay,
all
Doc.
see it. Yeah. Yes. So basically go up surfaces. Your mesh is already there. So just go up surfaces. Do you see surfaces? Do you see solid color surfaces? No, up. It's written. You don't surface.
Yes,
Debbie.
please.
Do you see it?
Yes, please.
Yeah. So surface with edges.
And select.
Yes.
Okay.
So you have it. Do you
Yes,
see?
please.
So you can make modifications. You can even increase the fineness of your mesh and all that. So for some of these geometries, you know exactly what to do. You can see that you've actually refined it. You can refine the edges.
Refine the edges.
So no, you can actually play with the numbers in there and see what happens. You know that 2020, 100, and all that we put in there. You can make the mesh finer by increasing those numbers. Not here. Close. Close this when you go into your block mesh dictionary.
Okay. So I have to go to the block mesh text.
Yes. Anyway, so let's stop here and pick up tomorrow. Because now that we've generated this, all we have to do is define our boundaries. So you can actually define your boundaries, and the boundaries are basically the inlet, the outlet, and then the walls. That's all. It's a very simple one. Do you want to continue?
According to our plan, we had up to one. Like you said, 3 hours. So I don't know if you want to.
Okay.
If you have the time and you want to get to the top of the hour. I think you are willing.
Okay. 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 So for this case, I'm just going to project the boundaries for you. So you realize that we did comment out the boundaries.
Yes.
Right? So just go in there And so let me just project that and let's finish that up.
But it looks like
So go back to your block mesh dictionary and then project. Hold on, let me share this with you. So this is what it's supposed to look like. Let me move this up. So this is what your boundaries are supposed to look like. So boundary, call it inlet, the type, call it patch. And then faces. So inlet is type patch. Patch basically means it's not a wall. So these are the faces corresponding to that. Do you see it? Hello?
yes, please.
Yes.
Yeah, so type this in.
Yes, please.
So make sure that the comments, the code is exactly this way. Let me know when you are done.
Okay, Doc.
All right. Then you want to probably have something somewhere. Yeah, this guy. Oh, nice. The good thing is it's successful. Do you have it? Let me see it. Hello?
You're almost done.
Oh, okay, nice. If you're done, let's see. Yeah. Actually, you guys did really well. This is nice. So this, you can see that the edges shouldn't be the same. It's just the boundary. That's what I want you to define. The edges is different because initially I used 100, but I want you to define yours to be exactly this because we've basically not changed the ordering.
Please, should we run the block mesh after we
Yes.
specify the bound?
Yes, after you specify the boundaries, run boundary conditions, and we are done. But let's pick this up because, yeah, I think it's getting late here. But if you want to complete it, that will be okay. But one thing I want you to do is to basically using your own, can you stop sharing? And if no one else is facing issues, is anyone else facing issues?
Yes, it's the same issue.
So then you should just use PowerView instead.
Yes, please.
Mm. Hold on, let me see.
Need to do this.
Anyway, so that is it, right? And so you can then just define the rest of it and complete it. Let me see if I have this issue. Okay, so we are done. And so the only thing I want you to do is try this. If you want hints, let me know. Oh, wait. So mesh generation, this is basically almost all of the complications you probably. So try to work this and try to get. Oh yeah, okay. So try this and show me what you have tomorrow. And I'm going to be leaving the parameters to you because you are engineers, you'd be able to come up with your own parameters for the geometry parameters. So just do that. So I haven't given you the length, the width, and any of the size. I want you to come up with those on your own. But then if you want any hints, let me know. Do you think there is going to be an issue? Do you want us to discuss it?
Oh, we'll try it.
I think so. I'm guessing this is also 3D, like it goes all the way.
Yes, this goes all the way, like it's 3D.
So means
So
that
I want you to generate it in
there
3D.
is a
Yeah.
way. Yeah. Okay. No, I
So
actually think this is very doable.
yeah, so with the pipe, once you've been able to do the pipe, I think this is relatively easy. Hello.
Yeah, hello.
But I'm just going to give you a hint here. So for the pipe case, we used edges, right? Depending on the way you define your geometry, you might end up needing different tools. For instance, let me just point this out here so that you'll be able to do it. Let's see. Let me see whiteboard. Okay, so let's see. Hold on. Okay, here. So let's say you decide that you are not going to do this. You are going to be cutting this along this line, right? Well, my drawing is not so good. Now, then you need to decide on where your origin is going to be, right? So you need to decide on that. So if you decide to have two blocks, for instance, so you have one block here and then another block here. Now the question is, what happens to the center point, right? So the face there, you need to merge them. You need to make sure that they are merged. Or if you decide that, hey, you are just going to use this and then go with this approach, for instance, so that I have one and two and two here, then you need to decide on what happens to this face. If you don't join it properly, then what then happens is you end up having two surfaces sitting on top of each other. That means anything that is flowing in here in this direction, it's not going to get here because this is now solid. So it's not going to be able to penetrate. So you want to make sure that these two are linked together, or these two are linked together if you decide on the approaches. So the way to do this is to use the merge pairs, merge patch pairs. And with the link I shared in the WhatsApp, you would see it there. So just make sure that you follow that, and that should be it. That's the only tricky part.
Thank you.
You get it?
Yes, please.
Mm. Yeah. So those meshing is the most critical point. Your geometry and your mesh. Once you've been able to do that, the rest you can just follow the various case files and make sure that your boundary conditions and the names of your patches actually match. And that is it. Anyway, thank you very much. And yeah, I think this was more informative than me doing everything and just showing you how it's done.
Thank you, Doc.
No, thank you, Dr. Nadi. No, we really enjoyed this section. Guys,
Oh,
no,
no
let's do
problem.
it for Dr. Nadi one more time, even as he leaves.
Thank you, Doc.
Thank you too. You guys did really well. Honestly, you guys did really well. And so, yeah, let's meet tomorrow and then try to at least finish this up and then see if we can add one more case.
Okay.
Okay.
Okay. Okay, so take care. Bye.
Okay, no, thanks. So
Okay.
we'll use Mozart to end the section.
All right. Okay. Bye.
So thanks, Dr. Baggy.
Look, we are waiting.
Oh, you guys can't hear.
No.